Okay, we have watersheds now, these basins where the precipitation falls into the basin, goes into the surface waters, into stream channels, and flows out one point. So that network of streams within the watershed can be kind of classified. The little streams flowing into the main streams are, so the little streams are tributaries. The main stream is the trunk stream. Water flows downhill because of gravity all down to this lowest point. The lowest point for all the watersheds is the ocean, that's base level. So a local watershed could be like a lake, especially like a dam, could be the base level for a stream. When precipitation hits the ground, it becomes surface water, and we can classify that runoff in different ways. Some of it we call base flow, so it's added to the groundwater and becomes, I'm going to take myself out of here for a sec. The base flow becomes part of the groundwater that sustains the flow in our rivers. Some of that water, that precipitation that hits the ground, as it becomes overland flow or overland storm flow, and that would be places where it's not going to infiltrate to become base flow. It flows over the surface, so it's on bedrock, maybe shallow, with shallow soils, parking lots, compacted grounds, unvegetated slopes where water can't infiltrate. So that all becomes part of overland flow. Most of the flows that are underground, right under the surface, is called subsurface storm flow. And that's going to be just in that top area where there's maybe some cracks, animal burrows, or pore spaces in the soil, or you have fractures in the bedrock. So base flow, recharging the streams, overland flow at the surface, and then subsurface flow. It's precipitation turns right into that storm flow. Okay, bring myself back here. Am I back? Wait, there I am. Okay. So if we look at water flowing into the stream, we measure that as a term called discharge. We use the capital Q as the variable. That's the volume of water flowing past a given point on a stream channel per unit time. So it's volume divided by time. And we'll look at the equation in another slide. That discharge in the stream depends on what is the size of the watershed. So we can designate a point in a watershed. Anything up above that is the area of the watershed. But as we move downstream, that watershed gets bigger and bigger and bigger. So the size of the watershed matters, and what point you're looking at in the watershed. The amount of precipitation in that basin also is going to dictate discharge, and how much water is lost through evapotranspiration, so evaporating back into the atmosphere, or transpiring by the transpiration by the plants. The comparing rivers, the Mississippi, it has the third largest drainage basin after the Amazon and the Congo of Africa. Those are bigger. The average discharge of the Mississippi is 17,300 meters cubed per second, or 611,000 CFS, and it drains, millions of kilometers squared of land. To compare, like 611,000 CFS, like the Watauga River, say running through Valley Crucis, is several hundred cubic feet per second. In the thousands would be a lot of water for the Watauga. All right, so measuring discharge, that volume of water. Turn myself off again, I think. The volume of water flowing downstream over a given amount of time. So it's reported as a volume, so a cubic measurement. And it's either going to be feet cubed or meters cubed, typically. Feet cubed is what the USGS gives out in cubic feet per second for the discharge. In the sciences, though, we like to use the units that the rest of the world uses, so oftentimes you'll see it reported as meters cubed per second. Either way, it's the length times the width times the height gives us a volume. So it's a cube. There's the cube of water there, that blue cube. I'm going to turn myself back on here. There it is. So the blue cube here, length times width times height. And yeah, so meters cubed or feet cubed. The time is usually seconds. We can do it in days or months or years and look at, discharge over different amounts of time. But for the most part, we're going to do CMS here, cubic meters per second, or CFS, cubic feet per second is how you'll see it written. The equation for discharge is area times velocity. So even though we're looking at volume over time, what's typically measured is the cross-sectional area of the stream is multiplied times the velocity of the water, and that will give you a cubic value for the volume, and then it'll be divided by the time. Yes.